In this video, I'm working in a PhET simulation called Balancing Chemical Equations. And I'm going to start by going to the introduction. And when you open up the introduction, it's similar to the simulation that we were looking at before, but this one here is a little bit different. You can see instead of the numbers of the different atoms being changed down here, actually the numbers that you can adjust in this simulation are the coefficients. And so in the last simulation, the coefficients were provided for you at the top of the screen, and in this simulation we're going to learn how to determine what those coefficients should be. So if I have a chemical equation, the coefficients tell me how many of each molecule there are going to be in order to make the equation balanced. And there are a couple of reasons why the chemical equation needs to be balanced. And these things are going to be shown with these scales at the top. So if I click this tool that shows the scale at the top, and let's just add one of everything. Well, what I see when I have one of everything, right? One molecule of N2, one molecule of H2, and one molecule of NH3, which is ammonia. Then on the left-hand side, I have two blue dots, which represents two different nitrogen atoms. And on the right-hand side, I only have one blue dot, because in order to make ammonia, there's only one nitrogen atom in that ammonia molecule. So if I have one molecule of N2, but I'm only producing one molecule of ammonia, there's a nitrogen atom that's gone missing. And so you should become a little bit of a detective in trying to figure out, do I have the same numbers of atoms on both sides of the screen? So on the left-hand side, I have two nitrogen molecules. Or sorry, I have one nitrogen molecule, but I have two nitrogen atoms. So on the right-hand side, I need to increase the number of ammonias, but you can see now that that's created a different problem, right? I have the two nitrogens on the two sides, those equal out, but now for each ammonia molecule that I create, I have three hydrogen atoms, right? 1, 2, 3, 4, 5, 6 in total. But on the left-hand side, I've only added one hydrogen diatomic molecule. So on the left-hand side, I have two hydrogen atoms. On the right-hand side, I have 6 hydrogen atoms. So I need to add more hydrogen atoms on the left-hand side. So I can do that until I get to 6. And you can see that once you get to 6, on the left-hand side, I have 2 nitrogens, right side 2 nitrogens, left side 6 hydrogens, right side 6 hydrogens. And I count all of those up, and I have the same amount on both sides. This is a statement about the law of conservation of mass. If I start off with that many atoms, then after the reaction occurs, I need to end up with that many atoms, the same number of atoms. And you can see at the top, you can count them as well, right? 2 and 2, 6 and 6. So it's just counting them up for you on the left and right to show that they're balanced. And there's one last thing that I want to point out. By using this simulation, it helps us understand that the numbers that go out in front of the reaction here, the coefficients are 1 and 3 and 2. Those coefficients, we don't get to decide what they are. There's certain numbers that have to be there in order for the chemical reaction to be balanced. And so apparently, in order to produce ammonia, nitrogen and hydrogen have to combine in this 1:3 ratio in order to make the ammonia. And maybe that makes sense because when you look at the ammonia, there's 1 nitrogen and 3 hydrogens. And so in order to produce ammonia, where the chemical equation is NH3, then you need to combine nitrogen and hydrogen in a 1:3 ratio.